after this week, the on what is it on December 8th. Okay, during my discussion section, I will do a final exam review. Okay, so during my discussion section, which is on Wednesdays, at 6:30 p.m. So look out for that. That is let's see, what is that? That is that is December 8th, 6:30 p.m. in Alan's discussion section. I will do a final exam review. It will be recorded. And I will post that to Blackboard along with the review sheet. The dates for the final exam are, and I will post this also, right? Because I just made this kind of determinations, but will be December 13th. That is what is that? That is a Monday, I believe. Yeah, December 13th, on Monday, December 13th, and the final exam will end on Sunday night, 11:59 p.m. on December 19th. Okay, so it will go from December 13th through the 19th. The final exam will be just like, the format of the final exam will be exactly like the midterm exam, 50 multiple choice questions. Okay, so that is what it is. Okay, I saw that quite a few people did quite well on the midterm exam. So you do what you're supposed to do, you will do quite well on the final exam, and we will come out of Urban Studies 101. Smelling like roses and all. Yes, I will be posting a review sheet, Sandra, as soon this week. Okay. All right. So all of those things, keep those in mind. I will post all of those announcements. Probably in the next day or so. So look out for that. I will post the review sheet this week. I will post the I will post a review sheet. I will have a review. We will be doing a final exam review after during my discussion section on since I'm not looking at my calendar right this second, during my discussion section on the 8th, then the final exam will be on the 13th through the 19th. Okay. All right. So I'm going to okay, so here's where I'm going to have to be mean. This is where I have to be mean, and I apologize, y'all, because I love y'all, but I got to be mean. If you miss 3 homework assignments, right? So remember, you have to complete 7 of the 10 homework assignments. 7 of the 10, which means you are allowed to miss 3 of them for whatever reason, any reason. I don't care. I don't have to know, but once you miss more than 3 homework assignments, it will begin to affect your grade. The same, it goes for the attendance to discussion sections. That's the same, it's the same rules, 7 of 10, right? I know a lot of now homework assignments are easy, are kind of easy to determine. Discussion section attendance is a little bit tougher because I've gotten a lot of emails from students asking how many discussion sections have I attended? And, part of me wants to say, well, don't you know how many discussion sections you've attended, right? One of the reasons why it's a little bit tough to say how many discussion sections you've attended is because it requires all of the discussion leaders to have recorded all of their all of their attendance in order for me to give you an accurate count, right? So if you ask me and say and say one person or everybody hasn't gotten all of their attendance recorded, then I might not be able to give you an accurate I might not be able to give you a fully accurate answer. So it's important that, of course, you keep track of those things. But if you ask me, I'll do my best to answer the question. Okay. And of course, once everything is tallied, once everything is tallied, we will know those answers. So, that's not, you don't have to worry about it not being recorded at the end of the semester. You don't have to worry about those numbers being inaccurate at the end of the semester. It's just sometimes it's kind of tough to tell you exactly how many discussion sections you have attended, right? Okay, if you just ask me. Right. So that's nothing wrong with paranoia. Well, yes, no, there is something wrong with paranoia. Don't be paranoid. Just do what you're supposed to do and you'll be good. And you will be good. So this is not a difficult class at all. But okay, all right. I am going to shut up because because we have a lecture to go through, and it's I want to go through it quickly. Well, not I don't want to rush through it, but I want to go through it kind of quickly because the lectures have kind of gotten big and very long, and and that's not the best. Okay, so we're gonna try to move through this a little bit quickly and see what happens. We're going to cover a lot of ground in this lecture because, of course, climate change and urban futures is a big deal. All right, so let's see. I'm going to begin. Actually, go here. Okay. Going to begin so if anyone has ever been to Union Square, right, you know that there's that funny building with the Best Buy in it in Union Square with the big, with the big thing with the numbers, right, and what it used to be was a clock. Right, it was called the metronome, and it used to be a clock. But last year, they changed the metronome clock in Union Square and they converted it to a climate clock. Right. And the purpose of the climate clock, and it's still going now, the purpose of the climate clock is to count down the number of years, days, hours, minutes, and even seconds before at our current pace of progress, we will be unable to maintain the global temperature rise of the 1.5 degrees Celsius benchmark that was set during the Kyoto Protocols, and then and ratified by many countries during the Paris agreements, and we'll talk a little bit about that later, right? So at the current pace, we are not on track to maintain those benchmarks that we set during those important climate accords. Okay, so you can go and check that out at climateclock.world, and you can also, of course, go to Union Square and check out the climate clock. All right, so now I'm showing this picture. And we can see that this is a picture of, it looks a picture of New York City. That's Lower Manhattan, right? That's Lower Manhattan, and you see that a large part of Lower Manhattan is dark. Okay, what's going on there? This is in 2012. Okay, right after Superstorm Sandy hit. Right, then there was a massive blackout in New York City as a result of Superstorm Sandy. It made landfall on my birthday on October 29th, 2012, right? Yeah, and it was, Chanel, it was crazy, right? I was in Manhattan at the time, and it looked like a scene out of a science fiction movie. It was so dark, and people were standing in lines. Oh, I'm really sorry, Andrew. That's and we'll say a little bit more about people losing property and things like that in just a minute, right? I hope that your grandmother was okay otherwise. There was a 13-foot storm surge, right? It was an incredible storm, something that's kind of unprecedented, largely unprecedented for New York City. More than 7 million people, of course, went without power, and there was an outage in Lower Manhattan for like 4 days. It shut down the New York Stock Exchange, right, for a couple of days. Massive transportation shutdowns and flooding. Okay, there was I don't know if y'all noticed this, but it seems like every time there's a big storm there's a really big storm in New York, the subways flood and there's massive, and there's quite a bit of infrastructure damage, right? We're going to say a little bit more about that a little bit later. But there was $62 billion in property and infrastructure damage in the United States. Very, very, destructive storm. And this is because one of the reasons why it was able to create so much damage was because the United States, by and large, and New York City in particular, was not infrastructurally prepared for a storm like that. So we'll say more about that. So this rate now, when I talk about when I use Superstorm Sandy as a lead-in for this discussion of climate change and sustainability and resiliency and all, but understand that any individual weather event or issue is not necessary. Doesn't by itself say, well, Superstorm Sandy, that's climate change. That's not how we talk. Rather, Superstorm Sandy is an indication of larger changes with regard to things like sea level rise and temperature rise that pretends that we will have more events like a Superstorm Sandy in the future, and therefore we should get prepared. So climate change is anthropogenic, meaning human activity driven average global temperature rise. That is what we are talking about when we talk about climate change. This temperature rise is due to increased burning of fossil fuels since the Industrial Revolution. So that's maybe like the early 1700s, and it has released large amounts of greenhouse gases, though primarily carbon dioxide, methane, nitrous oxide into the atmosphere. Right, those gases contribute to a more powerful greenhouse effect, which traps increasing amounts of thermal radiation in the Earth's atmosphere. It's not that now there, of course, the Earth has a normal kind of greenhouse effect, but what the release of those greenhouse gases into the atmosphere what they do is that it creates a more powerful greenhouse effect that leads to average temperature rise. However, of course, the world's oceans have absorbed the bulk of that excess heat, right? So it's not the case that that because it's hot in Miami, that's necessarily that's climate change, right? That it's a little bit more complicated than that. Okay. So a very good quick little illustration of what this looks like, of what the greenhouse effect is and what it looks like. So of course the sun The sun produces radiation in the form of ultraviolet, visible, infrared light. Okay, which hits hits the Earth, right? Now, much of that radiation is reflected by the Earth's atmosphere, right? By gas and clouds and dust and stuff in the Earth's atmosphere, which actually reflects which actually reflects much of that radiation. This is why we can see, say, like visible, see the Earth or whatnot from, say, like the moon, right? Because it reflects that radiation. So the sun's rays are reflected in space, but also quite a bit of radiation is actually absorbed by the Earth's surface, right? And that is what makes the Earth warm and able to sustain the kind of life in the ecosystems that we understand as part of our existence, right? Now, normally, a normal process is that a lot of infrared radiation is emitted by the Earth, right? Okay, and and it's just emitted into space. The effect of greenhouse gases in the atmosphere means that the radiation that is emitted by the Earth, right, is trapped in the atmosphere. Becomes trapped in the atmosphere and contributes to a general warming, like a greenhouse, right? And therefore, and because of the increase in greenhouse gases in the atmosphere, this has led to a significant increase and a significant projected increase in global temperatures. Now, of course, we're going to be talking in terms of only a few degrees Celsius, one way or the other, but a few degrees Celsius in average temperatures on the Earth creates major effects that can alter the life course of humans and other species on the Earth. We'll say more about that in a little bit. Okay, so let's talk about the atmospheric composition of carbon dioxide. So as of yesterday, okay, and that's a link that you can follow to a website that basically records the day to day the amount of the concentration of CO2 in the Earth's atmosphere on any given day, right? So as of yesterday, about 415.66 parts per million of carbon dioxide is in the Earth's atmosphere. Prior to the Industrial Revolution, right? Prior to about the 1700s, that it was more like about 280 parts per million. So since the Industrial Revolution, there is a significant increase in the concentration of carbon dioxide in the Earth's atmosphere. The last time CO2 was over the 400 parts per million mark was about 800,000 years ago, nearly a million years ago, which of course is prior to the evolution of Homo sapiens, or like modern humans, right? So what we're experiencing now is not something that humans have ever experienced before. The modern humans have ever experienced before, right? The high in 2016, the highest average temperature since had the highest average temperature since the 1880s, right? Was in 2016. Previously, it was 2015. That was the highest recorded temperature, and before that, it was 2014. So there's a kind of creeping up, right? The 2017 was the third highest, and 2018 was the fourth highest. All of those were still higher than in 2014. So even though it fluctuates slightly, we see that the average continues to the average temperature and the temperature continues to rise. Okay, and we can actually see this this rise in CO2 levels by studying the composition of ice cores. We can see this change in CO2 levels by studying the composition of ice cores. And so this is a study done of ice core data before 1958 on Mauna Loa in Hawaii. And so this is since 1958, and then of course after 1958, we see that over thousands of years, right? We see that, yes, it's true that the CO2 composition in the atmosphere has fluctuated. We see that absolutely. However, in just recent years, since 1958, we see that the concentration of CO2 in the atmosphere is kind of off the charts, right, compared to the previous hundreds of thousands of years. It is now kind of off the charts, right, and that is something for us to be concerned with. Okay, so now this is a chart showing the different levels, the concentration of different levels of greenhouse gas emissions in between 1990 and recent data to 2019. Okay, so that's about a 30-year period. We see that, of course, carbon dioxide, which is by far the greatest greenhouse gas that is emitted, right, and that is comes from the burning of fossil fuels, right? Methane. Methane, which is oftentimes attributed to industrial agriculture, such as like industrial meat production. Okay, nitrous oxide and fluorinated gases. Okay, but by and large, the burning of fossil fuels that produces carbon dioxide is by far the biggest culprit. And so we're talking in that way, we're talking about things like coal burning power plants, right, which of course fueled the Industrial Revolution and continue in modern power grids today, right, and of course in the particularly developed world, things like automobile travel, right, usage, and which of course individuals use automobiles instead of doing things like mass transit, right? Okay, so now in turn of globally, we see the economic sectors that produce the most, the largest amounts of greenhouse gas emissions, right? And we see that electricity and heat production, right? Let's see, agriculture and forestry and other land use, right? That's almost half right there. That's not counting industry and transportation and buildings, which of course, like heating and cooling buildings is also, even though it's only 6%, that's pretty high for just heating and cooling buildings, right? What is not kind of taken out of this particular chart is the use of say like military equipment in the U.S., but also in other developed countries is among the most polluting, the most energy inefficient forms of energy consumption. some of the most inefficient forms of energy consumption that we have, right? And of course, countries spend lots and lots of money developing their militaries and their defense capabilities. Okay, now what this does, what the production of all these greenhouse gases in the current day does, is it creates what we're going to call these feedback loops and tipping points. I'll say more about this. So scientists argue that that if immediate action is not taken, right, then what we'll do is we end up kind of passing a series of kind of points of no return, whereby our actions can't change the trajectory of climate change, and then they will trigger a series of self-reinforcing feedback loops. So increased warming will lead, of course, to CO2 emissions from the soil. This is an example. So yeah, the increased warming, it'll lead to greater CO2 emissions from the soil as microbes in the soil and animals become more active, right? Because when animals are more active, then they produce more CO2, right? So when they and of course they become more active when it's warmer. So for instance, in large parts of Russia, right, in like Siberia, it's covered in permafrost, meaning it's frozen all year round. And if it were to melt, if that permafrost, the microbes that are kind of suspended in the permafrost become more active, right? And then they produce more CO2 and large amounts of methane, because animals produce methane as one of their waste products. Right. Such changes might result in us leaving our current climate state for what is understood as an entirely new climate state. Right. So currently we are in a period. Often called the Holocene, right? And it's essentially a kind of interglacial period after the last ice age, and that's kind of where humans kind of developed, right? And this is a kind of environmental kind of feedback loop that sustains life as we know it. But when we produce more greenhouse gases and more greenhouse gases get trapped into the atmosphere, this changes the balance. This changes important balances that could send us into what scientists project and what scientists oftentimes call the Anthropocene, right, or the age of humans, or the age of man. Okay, I'm going to say a lot about what the Anthropocene is. Hold on one second, everybody. Okay. So this idea of the Anthropocene it's a basically, and we read some about it for this week's readings. The Anthropocene is understood. This idea of the Anthropocene is understood as the point, a kind of period during which the activities, human activity, can be detected in the geological record. For instance, everybody knows, like if you go like in that humans can study the environmental kind of record and changes in the Earth's atmospheric concentration of gases and things like that, and when things happen, by studying sedimentary layers in the Earth's crust, right? So you see in sedimentary rock, right? Well, only recently have humans been able to identify changes in the composition of the Earth's atmosphere as a result of increased carbon greenhouse gas emissions. We've been able to detect changes in the composition in the geological record, meaning that indicating that humans have a very, very powerful and large and real effect on the Earth's atmosphere and the larger environment. That's only become apparent recently, in recent years, and I will say a lot about what that implies and what's going on there. Let's see, where's mine? Here we go. So now this idea of the Anthropocene. Well, who's Anthropocene? One of the issues, when we say that, when we use the term Anthropocene, meaning the age of humans or the age of man, we have to, this is a little bit vague and maybe a little bit problematic. One of the important considerations for this idea of the Anthropocene is that it's not totally clear how long or the level of which or the kinds of human activity that have led to these kind of earth altering changes, right, in atmospheric composition. And that vagueness, because it takes place over a long period of time and it's hard to kind of see, it's hard for humans to wrap their minds around the scale of the environment and what human activity and its effects, right? And so because of that kind of vagueness and the vagueness of a term like the age of man, whatever that means, because people have been around for a really long time, this is it creates a kind of it contributes at least to a certain level of climate skepticism, right? This kind of skepticism that humans have had any kind of